Дорогие коллеги, пожалуйста, рассаживайтесь. Нам пора уже начинать. У нас следующее заседание, которое мы назвали лекционной сессией. И нам очень приятно, что сегодня у нас в гостях профессор Хироко Биссен-Мийаджима. Она живет и работает в Токио и является одним из самых известных японских хирургов, которые вообще есть в Японии, известны во всем мире. И мы очень благодарны, что Хироко приехала к нам сегодня и поделится с нами с достижениями, последними достижениями в хирургии катаракты. Мы знаем, что японские хирурги, они очень опытные, они очень широко практикующие, всегда на самом передовом рубеже всех научных и практических достижений. Please.
Thank you, Boris. Good afternoon, everybody. I would like to start my talk. So like my title, I'm going to talk about recent advantage, and I briefly talk about IOL design injector, IOL material, premium IOL including toric and multifocal lens, and image-guided system and femtosecond laser. It's going to be about 30 minutes talk. I'm going to quickly review all of them. So as Boris introduced me, I didn't understand Russian, but I come from Tokyo, Japan, and I'm currently professor and chair of ophthalmology Tokyo Dental College, and current president of Japanese Society of Cataract and Refractive Surgery, and president-elect in Asia Pacific Association of Cataract and Refractive Surgery. So I've known Boris many years, and he's been talking to many lectures at our meeting. And this is a picture of 2012 when he was invited keynote speaker at our meeting. So first, I would like to talk about IOL design and injector. So we would like to have a stable post-operative refraction and visual outcomes, and easy setting and insertion, and also fit for micro-incision. We've seen excellent live surgery this morning. So as for our design, I come from Japan, and I'd like to introduce one of Hoya's development. There's model 251, 255, and there's a modification of haptics, which make the smoother movement inside the cartridge and faster opening in the capsular back and easier removal of OBD behind the optics. And also, as injector, it comes with preloading system. It's easy to set, and also it can be inserted through smaller incision. So if we usually use IOL cartridge and injector, three materials, but if it comes with preloading system, just all in one. So I'm going to show you the video. You just inject the OBD. It could be also BSS because the movement is very smooth inside. And this part usually done by assistant or scrub nurse. But here I'm doing under microscope to show you. So it can be inserted through incision, and the lens opens inside in a good speed. And after insertion of the lens, you just put INA and center the lens and remove the OBD. And OBD behind the IOL, you can also go under IOL with eye tip, or you can use a rock and roll system procedure. So using this technique, we measured incision size with inner caliper, and final incision was between 2.20 and 2.3. Of course, you can use a wound-assisted technique, and it can be inserted under 2 millimeter incision. And when you look at the change of postoperative corneal astigmatisms, surgically induced astigmatisms was within 0.14 diopter, which is very reasonable for especially toric IOLs. So let's move on to IOL material. This is something exciting, and We prefer to have the material which will prevent posterior capsule opacity, and also we would like to see less glistening after the implantation. So this is a new approach to reduce posterior capsular opacity. We all know square edge is known to reduce PCO, but it is not perfect. So beginning with this new material, the iris surface is modified to increase the adhesion to the posterior capsule. Dr. Matsushima from Japan, he presented a nice video and he kindly shared with me, so I edited in short and I will show you with the sound in English.
We decided to modify the surface of the IOL to improve the absorption of adhesive proteins. UV ozone treatment was the method of choice for this purpose, offering both simplicity and effectiveness. Irradiation with UV generates free oxygen radicals. At the same time, the molecular bonds of the IOL surface material are cut and polymer chains activated. This generates COOH, OH, and NH polymer groups, rendering the IOL permeable to water vapor and nitrogen, which is important in improving absorption of adhesive proteins and adhesion in general. Fibronectin protein absorbed by the IOL was confirmed to exhibit excellent adhesion. We took LECs from white rabbits and seeded both UV ozone-treated and untreated IOLs. Then, cultured for 6 hours, cleaned, and compared the residual LECs still remaining. The untreated IOLs were sparsely populated. UV ozone treatment resulted in substantial proliferation, so we could assume better adhesion between the IOL and the capsule. We did more mechanical cell ablation testing to elucidate adhesive properties. This is the result. With an untreated IOL, the LECs were detached easily using a cantilever. In the case of UV ozone-treated IOLs, detachment was not possible at all. The question was, of course, does this improvement in adhesion translate into real results in terms of the prevention of PCOs? Let's take a look. To find out, we inserted UV ozone-treated and untreated IOLs in white rabbits. Here are the results, focusing on the center of the posterior capsule after 2 weeks. Of particular importance is the thickness of the LEC layer. In the case of untreated IOLs, there are multiple layers of LECs. With the UV ozone-treated samples, the layer is very thin, and there's almost no evidence of PCO formation. We now believe that using IOLs with squared-off edges and also modifying the material properties of the IOL to enhance lens adhesion can help us significantly reduce post-surgical problems to do with PCOs.
So it comes to the question, does this new eye reduce really PCO in your clinical cases? So we did a clinical trial 2009 and 2011, and we now have the result over 3 years follow-up, and I will share with you some results. There were 180 eyes, and this is the new material lens, and we compare to the control lens. And I briefly go through the result. And if you look at the posterior capsular opacity, you could see that new material with UV ozone-treated lens showed less capsular opacity, and this was statistically significant. And also YAG laser rate was smaller in a new material group. And glistening compared to the control group, you could also see the glistening is also reduced in eyes with this new material Vivinex, the model name. So it was approved in Japan 2012, and I've been using this lens, and I see the good result as a clinical trials. And this material will come to this country soon, and I hope that you will see the less PCO. So let's move on to the premium IOL. First, I'd like to talk about toric IOLs. You hear lots of toric IOL and multifocal lens session in this meeting. I would briefly review indication, model selection, and clinical outcome, and posterior astigmatisms. So when we look at the cataract patients, over 40%, actually at our clinic, 45% of the patients have the astigmatisms over 1 diopter. So that means that over 40% of the patients can have a benefit of the toric IOLs. There are several toric IOLs in the market, and here I would like to show you the results using the same base of Hoyer's lens. And this was already published in Journal of Refractive Surgery. So the 93 eyes were included in this study, and we follow up 1 year. And when we look at the uncorrected visual acuity, it was stable. And the astigmatism was also stable from 1 month to 1 year. And stability of IOL alignment, if we look at absolute change in axis mark and position, at between 6 to 12 months, it was less than 2 degrees. And when we look at the double angle plot of correction errors, this is with the rule group, and this is against the rule group. So with the rule group showed trend of overcorrection, and against the rules showed a trend of undercorrection. So we now knew why it happened, because at that time we didn't consider posterior astigmatisms. But now we can measure both anterior and posterior corneal astigmatisms. And of course, you know the many publications, and also a very important publication from Dr. Douglas Koch. And using this, I think our clinical data will improve. So as for multifocal lens, there are different near addition in the market. And I will share with you our clinical outcomes, and also the outcomes with contralateral implantation. And also I'd like to introduce the result of trifocal lens. So at the beginning, we only had 4 diopter near addition, but now, 2016, we can choose the IOL with suitable near addition. And also, some of the lens has the astigmatism correction. So how we choose? The reading distance is different, and we can choose the different near addition. This is 30 centimeters and 40 centimeters. And all the lens has the different character. So when we look at the distance visual acuity, all achieved 20/20. And when we look at intermediate visual acuity at 1 meter, of course the lower addition of 2.5 shows the best result. However, when we look at near vision at 30 or 40 centimeters, +4 or +3 near addition shows better result, which will end it the less reading glasses dependency. So which near art to select? 4 diopter was the typical art for the first generation of diffract multifocal lens. And this is preferable for especially Japanese patients who read Japanese characters. This is our newspaper, which is written lots of Chinese characters. And you could see the reading distance is probably shorter than what you do. So 4 diopter addition is still very popular in Japan. What about +3 diopters? So reading at 30 meters is a bit difficult. But for those who read at 40 to 50 centimeter works very good. And when we look at 2.5 diopters, for reading, patients should be prepared to use reading glasses, but we could have better distance visual acuity because of the low addition. But also, we can think about contralateral implantation. That means one eye and another eye is different addition. And we published already +4 and +3 in Asia Pacific Journal of Ophthalmology, and we could see the distance visual acuity will increase with contralateral, and also intermediate and near visual acuity is better than unilateral implantation. So we could also think about not only 4 diopter and 3 diopter, 3 and 2.5, or other combinations. And also, we have a trifocal lens in the market. We had experience of fine vision or physio. This IOL is not approved in Japan, so clinical use was approved by IRB. And I would like to show the result. This is the non-toric group and a toric group. And both groups showed good uncorrected visual acuity. So there are several ways to adjust multifocal lens to patient individual lifestyle. So we can think about bilateral or contralateral implantation of bifocal lens, or bifocal implantation of trifocal lenses. So now I would like to talk about image-guided system. So for toric lens, this is a great machine, and I would like to compare with previous marking system. This is a previous one. We make first reference mark and confirm the axis of the lens in OR, and we make an axis marking, and then we will adjust the lens axis. But if you have image-guided system, you just match the image preoperative examination and under microscope, and video overlay shows the steep axis. So this is very easy procedure and very precise, and I would like to show the monitor of the image-guided system. This is a Callisto of Zeiss, and our technician is just operating this Callisto and matching the vessels, then confirm, and after phaco emulsification and implantation of the IOL, we can adjust the IOL axis to the video overlay, which will be really easy for the surgeon. And even the eye movement, this line will follow, so we can confirm at the end of surgery. So finally, I'm quickly going the very many fields, but finally I would like to talk about femtosecond laser. I saw my teacher, Professor Zoltan Nagy here. I went to his clinic and I learned, and I was very impressed, and I started 2013. So currently we have 30 lasers in Japan. I don't know how many in Russia. And LensX and Catalyst are only approved femtosecond laser. First, I will show my surgery. I put the laser in the same room of an operating microscope. So first, we just confirm the OCT. And this procedure you've seen many times with different congresses. I do also cornea incision. After anterior capsulotomy, the lens fragmentation, the green pattern, or whatever. When we have a very hard nucleus, I use a 6 division. And then at the end, making a cornea incision. So we just moved the patient's chair probably 30 centimeters. I've seen the OR in this beautiful clinic. This system is completely different, but this is a small movement of the chair. And I use a slight phaco emulsification and insert the toric. This is multifocal lens. This is another image-guided system, and adjust the axis. So this procedure is increasing at our clinic. And here I would like to show the very effective way. This is the patient who had a traumatic cataract. You could see this places that zinsonular was defect, and the patient had a very strong cornea astigmatisms. The young patient, and she wanted to have a multifocal lens. So I decided to use the femtosecond laser. And corneal astigmatism, because of this zonula, I didn't dare to use the toric lens at the beginning, and I corrected the astigmatisms. First, I moved the anterior capsulotomy a little bit far from the defect of the zonula, and I made a lens and corneal application. And this is under microscope, use the viscodelineation. And the lens is released and already divided in 4 pieces, so you can smoothly use the phaco tip inside the back. And after phaco, I inserted the capsular tension ring. And then we moved the cortex with INA. This part is very smooth. Of course, you could do without laser, but because of the laser application, the procedure was much safer and stable. And multifocal lens, Technics multifocal was implanted, and the lens was over. So at the 3 months later, I did astigmatism correction by LASIK and distance visual acuity 0.7 near 0.4, which is not perfect, but for those patients who had this type of traumatic cataract, this visual acuity is very reasonable, and patients is very happy. So benefit of FLAX is stable size of anterior capsulotomy, reduced US time, and application for complicated cases, which are already known. But here I'd like to show you the benefit of FLAX in a different way. What about the benefit for the surgeons in training who are starting to learn cataract surgery? So does FLAX shorten the learning curve and reduced intraoperative complication? So anterior capsulotomy, dividing nucleus, those procedures are difficult part. So why shouldn't we try and see? So we did a wet lab and learned the laser operation and applying laser procedure for thin eyes and continue phaco and INA as usual wet lab. We don't have such a beautiful wet lab system at our clinic, so Alcon has this system with femtosecond laser and phaco machine, so we usually go there and do wet lab. And the young surgeon learn how to operate the femtosecond laser and actually applying the laser. And not only the laser system, she also continued to the phaco procedure under microscope. So we practiced, or she practiced, until she felt comfortable with the procedure. So I will show her second procedure, second case. If you look at this video, probably you don't recognize she is a very young resident. You can lower the sound if you can. Of course, you could see the cornea incision a little bit, she's a bit awkward. I didn't let her try cornea incision from the beginning. I first let her try capsulotomy and lens application and putting the viscoelastics. I think this part of the cornea incision she can try later on. At the beginning, I let her try press chopper to be sure the lens is divided. But after 5 cases, she didn't use any press chopper. She can just, use the phaco tip, and lens is already divided, so it can be easily done. And the surgical time for the surgeon in training, for example, resident, we can imagine about 10 minutes. She managed. So this is some new technique for the surgeon in training. Of course, the laser is expensive and you cannot dream to have everywhere, but I think this might be in the future. So personal experience, impression flux for surgeon in training, such as resident, I think definitely can reduce incomplete capsulotomy and unnecessary capsular vascular during lens manipulation. And the whole process of cataract surgery can be done within first 1 in 5 cases. And less stress for both learning and supervisor. And then always I was asked, what happened to the manual capsulotomy? After using this technique, the surgeon is already be sure of using the instrument under microscope. I think even manual capsulotomy can be easily learned. So I would like to summarize my talk. I mentioned the preloaded system to fit the micro incision is useful, and introduced a new material, UV ozone-treated IOL. And I briefly reviewed the benefit of toric and multifocal IOL. And I showed a markerless surgery, and flax is beneficial for complicated cases and surgeon in training. So we will have a 2019 APACRS Asia Pacific meeting in Kyoto, Japan, and I hope that I will see some of you there. Thank you for your attention.
Уважаемые коллеги, давайте поблагодарим японского профессора за блестящую презентацию. Спасибо.
Thank you.